Alrighty, so today we're going to look at 3 questions. So these are ones that have just popped up and that you guys have let me know that you've struggled with a little bit. So hopefully we can do, a couple of these and then you should be right. So they're from chapter 5, Linear Relations. The first one we're going to look at is from 5G. So this chapter was focusing on having variables on both sides of the equations and then solving for that variable. So let's do this example, and these are just out of your textbook, so most of you would have done these already. What I would do with these worded problems is use a highlighter to get the key parts, okay? So we've got at the school canteen, the cost of 3 apples and 5 oranges is the same as the cost of 7 apples and 2 oranges, okay? Let A represent the cost of an apple in cents. They're probably the keywords for me. So pulling that out, A says I need to write an equation to represent the situation. So we're talking about cost. The cost of 3 apples. So 3 apples. We're going to write A because we don't know what the price of an apple is. So we just write A. Plus 5 oranges. Now, 5 oranges, over here, oranges are 80 cents, okay? So we need to figure out, well, how much is 5 oranges? So, why have I put 0.8 there? Okay, because I'm writing it in cents of dollars because that's how we do money, okay? So 80 cents to me is $0.8. It doesn't really matter as long as you're consistent. So later on, if, a number comes up that it's $1.60, it would be 1.6. That's all in dollars, okay? It just gets a bit tricky once you go over. So if you've got 400 cents, that's $4 to us. Just make sure you're always writing it. So at the moment, I'm going to write this in dollars. So anyway, I've got that first bit, and I highlighted the same because that's where our equal sign comes from. Okay, if something's the same, it is equal to. And it is equal to the cost of 7 apples and 2 oranges, which again are 80 cents. Okay. So let's just simplify this a little bit. So the equation to represent this situation is 3a plus 5 times 0.8. We would get 400 cents or $4. So plus 4 equals 7a plus $1.60. So 1.6 because 2 times 0.8 is 1.6. So that's our answer for that one. We're just writing an equation to represent the situation. B says we now have to solve the equation. So I'm going to rewrite it. Plus 1.6. Okay, so when we're doing these questions, we need to get the variable, okay, or the letters on the same side. So I've got a 3a and a 7a. What I'm going to do is get rid of the smaller one. That's generally a good rule to go by. So 3a is smaller than 7a, so I'm going to get rid of that. Now, when I say get rid of, we need to do the inverse operation. So at the moment, it's a positive 3a because there's not a minus in front of it. It's a plus there. So what's the opposite of a positive or a plus? We would subtract 3a. Okay, now we've got to do the same to both sides to keep it balanced and equal. So we minus 3a from both sides. Okay, the reason we do that is that now cancels out. So we're left with 4 equals 7a minus 3a is 4a. And we've still got that plus 1.6. Okay, so we're solving the equation, which means we need to get the a by itself. Okay, so we're going to keep doing our inverse operations for this one to get the a by itself so that we know the cost of an apple. So let's, we've got a 4 next to the a here, and we've got a plus 1.6 next to the a. So let's get rid of the 1.6 first, because if you know how to backtrack, you would know that that's the next one to go first. So it says plus 1.6, so we're going to minus 1.6. 4 minus 1.6 is 2.4, And the reason we do this is that cancels out, so we're left with 4a. All right, so I'm just going to go over here. 2.4 equals 4a. Again, we've still got this 4 next to the a, so to get rid of it, it says that any letter next to a number is times. So 4 times a. So what's the opposite of times? Well, we would divide by 4. And we have to do the same on both sides. All right, so that cancels out, and 2.4 divided by 4 is 0.6 equals a. Okay, so apples cost 60 cents, okay, or $0.6. They're the same. All right, so yes, setting up your equation is a matter of highlighting the important parts of it and then, yes, setting it up like I did over here. Another thing when you're talking money, make sure that you understand, or are consistent with whether you're writing it all in cents or writing it all in dollars. I went with the dollars because that makes more sense to me. And when you're solving equations, you're trying to get the variable on its own, by itself on one side of the equal sign. To do that, we use our inverse operations. Okay, if we've got the same variable on each side, find the smallest variable and get rid of that first. Alrighty, I've got a couple more. So here's another one from 5G. I find these ones still, can trip me up, so they're just ones you need to practice. So let's look through it. Let's get a highlighter. All right, Sean poses this problem to his neighbours. In 4 years, I will be 3 times as old as my cousin now. 2 years ago, I was twice my cousin's current age. Can you work out how old am I? Let A represent the current age of Sean's cousin. Okay, there's a lot in that. But pretty much he's giving us 2 options of, his age compared to his cousin's. So in the first bit, A, it says one expression for Sean's current age is 3a minus 4. So they've gotten that from, and I'll do it in green highlighter. So it says that Sean, he will be 3 times as old as his cousin now. So that's where this 3a comes from. Okay, but that's in 4 years' time. So that's why it's got minus 4. Now, a lot of you might think, well, plus 4, because in 4 years' time, that's how old you'll be. But if you think about if we go 4 years in advance and he's 3 times the amount, okay, we're wanting to know now. So we need to go back 4 years to the now. That's why it's a minus 4. Okay, because it's in 4 years, he will be 3 times the age. But right now, so we need to come back 3 years, or 4 years, sorry. So these ones can be a little bit difficult. So let's look at the next bit, because it says, what is another? And it's told us that in the question. It said, so 2 years ago, I was twice my cousin's age. Okay, so twice my cousin's age, and we're letting A be the cousin's age at the moment. Okay, so twice would be 2a. Okay, we're twice this age, but this was 2 years ago. Okay, now if we go back 2 years, okay, he was twice that age. That's why we have the 2a. But we're talking about the now, so we actually need to add 2 years onto that. Okay. Again, that hurts my head, but you'll get used to it. All right, because 2 years ago he was twice the age, which is the 2a. But we're talking about the now. So instead of being 2 years ago, we need to add 2 years to be in the now. So that's where the plus 2 comes from. All right. B, use the expressions in part A to write an equation. So from that, we know that one expression is 3a minus 4 that tells us Sean's age. And that's the same as this expression that we just came up with. That also tells us Sean's age. He's just given us 2 options, pretty much. Alrighty, so that's B. We've written our equation. C, we need to solve the equation to find the age of Sean's cousin. Because remember, A is Sean's current age of Sean's cousin. So let's find out how old the cousin is by solving this. So we need to get the A on its own. All right, so like the question before, we're going to look at, we've got variables on two sides. What's the smaller one? The 2A is smaller than 3A. So we're going to subtract 2A from both sides so that goes away. 3A minus 2A gives us 1A. And then we write the rest of the equation as it is. All right, we still have this minus 4 next to the A, so we're going to do the inverse operation. So instead of minus 4, we're going to plus 4 to both sides. Therefore, A equals, because that goes away, because minus 4 plus 4 is 0. That's why I say it goes away. Equals 2 plus 4, which is 6. So therefore, Sean's cousin is 6. Okay, now D says, how old is Sean? So Sean is either this age or this age. Okay, remember we have two examples. So pretty much if we substitute in Sean's cousin's age, because we know that he's 6. So let's substitute it into this equation. Now it'll work for both. So instead of A, we're going to put 6 because we know that that's how old he is. 2 times 6 is 12 plus 2, which is 14. All right, so that would mean Sean's 14. If you chose the other expression, which would also be fine, so let's go 3A minus 4. Putting in the 6, so 3 times 6 minus 4. 3 times 6 is 18 minus 4. 18 minus 4, is 14. Which is the same as what we got before. So either one works, and it should work because, like we said, they equal one another. So we should have got 14. All right, so Sean's cousin is 6, and Sean is 14 years old. Alrighty. Again, can be a little bit tricky with the wording, but the more you do, you will get better at it. We're going to do one more question. This one's from 5H, so it's plotting, points on a graph and reading from that. So let's get out our highlighter and have a read through. Emily is making ribbon streamers for her cheer squad, but needs to work to a budget of $40. The length of ribbon she can buy depends on the cost of the ribbon. So the length of the ribbon she can buy depends on the cost. So A, copy and complete this table. Now, I'm not going to do that. So I'm going to put A over here and I'm going to fill in this table. So she has $40 to work with. Okay. So if she was to buy material that cost 50 cents per meter, okay, that's what that first one is, then how many meters will she be able to buy? So with this, I would be going, well, she's got $40 and I'm going to divide that. How many 50 cents fit into the 40? Okay. So you can do that on your calculator, or you might know it's 80. Okay, so she could buy 80 meters of material at 50 cents each, and that would fit her $40 budget. Okay, so I'd be working along. We've got to fill in this table. So we've got, if she buys material that's 80 cents, how many meters can she do? So again, you would do 40 divided by 0.8, which should be, now I've done these calculations earlier, so let me get that up. It should be 50. All right, and so on. So 40 divided by $1.60, you would get 25. 40 divided by $2 is $20. 11 and 8. Alrighty. So we've done A. B says draw a graph of this relationship. B. Right. Drawing a graph is very important because you need to get the numbers accurate, or the scale accurate. So I don't have a ruler, but I really implore you to use one as well. So I'm going to try my best. So we're going to do a big graph like this. Which one goes on the x-axis? Which one goes on the y-axis? Okay, usually when you do your tables, it's always the X on the top and Y down the bottom. Okay. It also says in the question, the length of the ribbon she can buy depends on the cost of the ribbon. So that means that because the length depends on it, so it's dependent, the length, the dependent all goes on the vertical axis. We'll talk more about this another time when we look more at graphs. So anyway, we need to label our axes. So this one would be M, so meters, because it's length. Sorry, this is already looking messy. All right, and then going along here is our cost. So it's dollars per meter along here. Quick little thing here. Why haven't I done axes like this? Why didn't I do this? The reason being that we don't have negative dollars, okay? We're not going to be, Emily only has a budget of $40, so we're not going to go more than that. So we don't need the negative of this. And it's impossible to have negative 5 meters of ribbon. Okay, so we don't need the negative part here. That's why I've done that. Just a little heads up for you all. Okay, next part is getting our scale correct. What that means is putting our numbers across our X and Y axis. So let's look at the per meters. So we're looking at this, this bit here. Okay, I look at your minimum and your maximum value. So minimum is 0.5 up to $5. Okay, so we want to go up to $5. So what I might do is, obviously up here we can put 5, and I might go up by 50 cents. Okay, so I'm going to go, obviously halfway is going to be $2.50. So I might go 2, 1. So that would be 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. Putting our numbers along, 1, 2, 3, 4. Again, if you guys are using a ruler, this will look a lot better, and I really need you to use rulers. All right, and then we're going to do our length. So looking at the next bit, our biggest number there is 80 and our smallest is 8. So I want to go all the way up to 80 here. What I might do is go up by 5s, I think. So an easy way to kind of do that, I know that half of 80 is 40. Okay, half is 20. This is just to get your scaling, you know, as accurate as possible. Which means half of those are 10. And then we want to go halves again because we want it to be accurate. If we're going to go up by 10s, it might be a little bit harder to see, you know, these numbers of 8 and 11. So I think we go, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. That's, not neat, but you get it. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. All right, so let's plot our points. So the first one I'm going to do is at 50 cents, she gets 80 meters. So at 50 cents, she gets 80, so you're going to have a point here. At 80 cents, you're going to get 50. So just before the 1 along our x-axis, because that's, 0.8, we're going to be at 50. So I'm going to put it about here. $1.60, so 1.5 and a little bit more is 25. At $2.20, I'm going to go here. $3.60, so 3.5 with a little bit more is at 11, so just above the 10. And at 5, we've got 8. So about here. All right, so there are all our points. Let's put a line all the way through them. There we go. So that's B. So going back to C, or going to C, is the relationship linear? Is this linear? No, it's not. Why? Or explain? Because it makes a curve. See how he drew that line through it? It's making a curve. Linear lines are straight. So you could write it is not straight. Or lines form a curve. Sorry, not lines, points. Either one of those is fine. All right, D. Use the graph to find how much ribbon she can buy if the cost of the ribbon is. So we've got $2.50 per meters. So looking along here, our $2.50 is here. So we're going to go up to my line. So we're looking here, okay? What is the length? Okay, I'm wanting to know how much ribbon I can buy if it's $2.50. So if I go along here, I can look at how much I could probably buy. So doing that, it's just above the 15, so I'm going to say about 16. If I could get 16 meters if the cost is $2.50. 75 cents, so that's 0.5, so 7.5. So I'm going to go all the way up here. So going along here, what is that? About 53. So, these are all approximations, but you can get it pretty accurate, as long as you've ruled it pretty well. And number 3 says at $4.20. So $4.20 would be about here. So how much when we are here? Let's go along. All right, it's just under 10, so it's about $9.50. Oh, sorry, 9.5 meters, or 9. I'm going to go 9.5. Okay, so you'll notice in the answers it should say the word approx because everyone will just be a little bit out because we are getting our answer from a visual representation or from a graph, so it can be a little bit difficult. And last one, D. Emily needs at least 32 meters of ribbon. What price range should she consider? So 32 meters. Let's have a look on our graph. Where's 32? About here. So let's go across to our line. Okay. And let's have a look at how much she needs to spend. So again, this is from my graph. It looks like just before $1.50. So you could say maybe $1.30, $1.20. So $1.25 would be here. Just depends how accurate you draw it. Yeah. So I would say $1.25 for 32 meters. So she needs, what price range? Between 0, or probably not 0, because it won't be free, but up to $1.25. So anything that costs more than $1.25, she won't be able to get 32 meters. Okay. All right, I hope that helps and makes sense. Make sure you reach out to your teachers if you need to, and good luck with your CAT coming.